Okay, this video will explain the computational construct fixed loop. Computational constructs are the building blocks that programmers use when they're constructing their code. When they're writing code, they use computational constructs. There are a lot of computational constructs. The sequence of instructions is a computational construct, an assignment statement, a fixed loop, a conditional loop, iteration, a selection statement. These are all examples of computational constructs. Today we are just looking at a fixed loop. What is a fixed loop? So you can see here a fixed loop is a computational construct. It allows a line or lines of program code to be repeatedly executed a fixed number of times. Because if you think about it, under normal conditions, when you write your program, the computer translates and executes each line one at a time. As soon as that line has been executed, it's discarded and the next line is loaded and read. It needs to be instructed to go back up and read lines of code that it's previously executed. Otherwise, that will never happen in a program. The thing about a fixed loop is you instruct the computer how many times to go back up and execute specific lines of code. Now here is the syntax for Python, and you can see here that there's two lines of code. The first line is the for, so you can see this keyword for, which is a different kind of reddy colour. Loop counter in range, and there's the number 10 inside the brackets of the range function. The colon, and then you've got indented code inside this for loop. So what happens in Python is any code that's indented under the for loop will be executed the number of times that's stated in the brackets of the range. So it's easier to understand this if we program a solution to a problem. So here's the problem. Display the countdown sequence to the Apollo 11 space mission. So I've got my Thonny file here. Let me just see the problem and get my Thonny file. Right, I have set my Thonny file up so that I can see the instructions exactly the same as they are here. My shell is a larger area because I'm going to output 10, hopefully, start engines 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Okay. I've also got this section here, variables. If you have not got this displayed in your Thonny, then go to the view menu and click on variables. And what this will enable us to do is watch what's happening, what values are being stored in any variables that we have in the program. And we've got one variable at the moment, it's called loop counter. So you open up Thonny, type in your code, save your file as for loop version 1, and then let's run it and see what happens. So I'm just going to press this start button. You could also click on F5 in your keyboard and look what's happened in the shell just as quickly as possible. Here we have the chevrons to indicate the start of the program. It's telling you the name of it, and down here you have your empty chevrons to tell you that the program has terminated. So this is the output that's been generated by this code. Now you can see in the code that there is only one print statement, and it says print loop counter. And what's actually been printed out here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's actually 10 print statements have been executed to print 10 lines of code, and what has been printed out is the value that was stored in the loop counter. Now as the program has terminated, this variable loop counter contains the value 9, and 9 is the last value that was printed out. So what we'll do next is we'll slow down this execution and we'll step through it step by step to see what's happening, what the computer is doing, how it's been processed. So let's clear the shell. So we start with our empty chevrons, and then what we want to do, instead of clicking this green button to run it, or F5, we'll go into the run menu here and we'll choose debug current script nicer. So it's Control 5 on your keyboard. I'm just going to click this. Now the code is highlighted, you can see that it's turned yellow, and we've got extra controls here. We've got step over, step into, step out of, or resume. So what we want to do, we don't want to step over it, because if we step over this code, the program will end. What we want to do is step into this for. So step in, and it's saying for loop counter in range 10. So it's going to deal with this range 10, and what we want to do is step into this as well. So let's step into range 10, and it's highlighted 10. So let's step into that and see what the program is going to do with that. It's made it green. And it's saying, well, that actually means the range from 0 to 1 less than 10, which is why we ended up with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in our shell. Okay, so when you write 10 in there, what's actually happening is the start of the range is always 0, the comma tells you the starting point of the range, and the end point of the range. So that means this loop will go round 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It won't go round. When it gets to 10, it knows it's too far, it's out with the range. The loop will stop executing, and if there was a line 3 in this program, that would be executed next. So let's continue stepping through this. So the whole loop counter in range 10, and what we've got here is 0, so we know that 0 is the first value, and because this is the first time this loop is going round, that's the value. Okay, so our variable loop counter has been updated to store the value 0. And the code has moved down, and it's this print loop counter that's now going to be executed. And we know that loop counter currently contains this value 0. So let's step into. So print loop counter, we've stepped into that. Let's see what's happening. So what is in loop counter? That's what the computer is checking next. So let's see what it does. Well, actually, it knows loop counter has 0 in it, so the statement is going to print 0. So print 0 is what's going to be executed, and it's been executed. It's saying none here because there's nothing else to execute on this line. The printout hasn't displayed to screen the number 0, so let's keep going. So the loop has went back up to the top, and this time 1. So we've moved on from 0 and we're now at 1. So let's keep going. So we're down to loop counter. Loop counter has been updated to 1, and we're about to print out what's currently in loop counter. Print 1, and print 1 is executed. Okay, so let's continue up again. So we're back up to our 4 at the top of the loop, you can see the range now occupying 2. It's been incremented, so we can carry on. Print loop counter is going to print out 2, and it prints out 2. So we can keep going. We're now 3. So you can see that every time this loop goes round, this number moves along from 0 to 9. And it's now going to print out that value that's stored in loop counter, which is currently 3, and there it is. That's finished terminating that line, so it goes back up to the top of the loop. It's now moved along to position 4 in that range. Down to the print, it's checking loop counter. We can see that it contains 4. And if we just keep going, just click through, you can see what's happening. Yeah. So what can we tell from this? As you're stepping through this, what's the purpose of this loop counter? We're nearly finished. So there's nothing else, so we've got one more to do, and you can see the program has terminated. And that's why loop counter had the value 9 in it, because that was the last value in this range 10 from 0 to 9. Now, if we look back at this, we can start to label it. So let's get a pen and we'll label this diagram a bit better. So I can say that this loop counter for definite, that is a variable. So that is a variable. And what data type is that variable? Well, if we look back here, we can see that it's always been a whole number, isn't it? It's always been a whole number that's been printed out. So that means it's an integer variable. Okay, and we can tell what is the start value. I'm going to change the thickness of this. So the start value in this instance was 0. And we can also, let me change the colour of this, we can also see this indentation here. So this is an indentation, it's an indent, and all code indented under the 4 is repeated. Yeah. And we've got, let's change this colour, we've got one line which is repeatedly executed. So this line of code, this line of code is repeatedly executed. Okay, and we can also, let's get a different colour, let's go for a green. We can also have a look at this range, because if you remember, and go back and look at it, step through it again if you've forgotten, but this range function, so the range function has got a start of the range, and the one we did ended at 10. So that actually means it's going to iterate through the numbers. So let me just put them through in 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And if we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that refers to the 10 that we had typed into the brackets here. Because we know that this is the start value, 0, it's going to count up 10 iterations, 10 loops of the loop. The first loop, the second loop, the third loop, the fourth loop, the fifth loop, the sixth loop, the seventh loop, the eighth loop, the ninth loop and the 10th. So this is the loops. 1, yeah, and it knows not to go round another time because it has looped 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what's happening behind the scenes. What we need to know is the number we put in here is the number of times the loop will actually repeatedly execute the code which is indented inside it. Right, I hope that's made it a bit clearer for you and you can quite confidently use the fixed loop to solve some problems. Don't forget that colon there. Now, have we solved this problem of displaying the countdown sequence to the Apollo 11 space mission? Let's get our program back up. Now, I said that I wanted it to state, first of all, start engines, and then count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But ours is printing out 0 to 9. So let's fix the first problem. I'm going to bring that down a bit so that I can see this code, because we need to put a line of code in above this. What we need to put in here is a print statement which says start engines, start engines. Okay, let's save that, Control S and F5 to run it. And now if we go back up to the top here, it says start engines 0, 1, 2. So we've got start engines, but it should say 10, 9, 8. Let's clear the shell. And at the end, we wanted it to say blast off. So if I put print blast off in here and run it, Control S to save it, then what we're getting here, because this is indented inside this for, every time this loop goes round, it's actually executing both of these lines of code, which is why we're getting 0, blast off, 1, blast off. What do we need to do to this line, blast off, this print statement, so that it only prints out once after this loop has finished executing? I'm going to clear this shell, and hopefully you have answered that question. All we need to do is backspace it to the edge of the program so that the computer knows that this line of code is not part of this for loop. Right, let's save that and check it to see if it actually works. Let's test it. So we'll run it. There we go, blast off. So we've got start engines, we've got our count up and blast off. So we've got one more thing to do, and that is to swap this so that it does, the start number is not 0, it's 10 even. Will we try that? So remember, when we were stepping through it, we saw that range was 0, 10. So I wonder what would happen if we put 10, 0 in there. Right, let's save that and see what happens. Oh, I need to clear this, don't I? Nothing has happened. It doesn't like that. Start engine, blast off. So it's printed out start engines and it's printed out blast off. The computer has not understood this instruction, so it's not printed out print loop counter. So we can't do that. So that means that we're going to have to do something else. We'll start at 1 and we'll finish at 11 and we'll go backwards. We'll go in -1 steps. Let's see what happens if we do that. So we'll clear this shell. We'll save this and let's run it. Okay, so it doesn't like that. So why don't we try turning these numbers round and see if that's going to help. Right, so let's try making that 11 and making that 1, and then we'll clear the shell and we'll try again. So save it, run it. Right, we're nearly there. So what have we got? So we've got 11 because it started at 11, and we've got 10, 9, 8, 7, 6, 5, 4, 3, 2, and then blast off. That's not so good, is it? So what do we need to do? Well, we need to change that to 10, and I would say that we need to change that to 0 because we remember we said that that's the stopping value. It always stops before and checks when it gets to that value and it doesn't iterate again. Right, let's clear that, save our program file and run it. Right, that looks good. So we've got start engines 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. That looks good, doesn't it? Now, do you think we could format this so that the numbers are in the middle of start engines and blast off? Let's try. So let's count up the characters. So we've got 1, 2, 3, 4, 5. Remember the space is a character, ASCII code 32. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So half of that is 7.5. So that's 5, 6, 7. So we want it to be here on the E. So how do we do that? Well, what we can do, change this print statement into a format. So we could say here, put in our speech mark, curly brackets, dot format, close the brackets. You need an extra bracket there to close because we've got print bracket and the format bracket, so you need 2 closing brackets. And this is the placeholder. Remember, we've discussed this before. So in your print statement inside these speech marks, whatever value is stored currently in this variable will be displayed here. But we need to tell it how to display. So we put in a colon here and this caret symbol, and we need to, which means in this instance it means format it centrally. So you need to tell it how many characters to center it on, and we've counted up 15. Right, let's save that and run. Oh, let's clear that first and then run it. There we go, that looks better, and it has indeed centered on the E and the N. So that looks better, doesn't it? So start engines 10, 9, 8, 7. Thing is, it happened really quickly. Could we slow it down, this processing? Is there a way to do that in Python? Well, it turns out there is a way to do it, but it means that we have to introduce a module into our program, the time module. The code can instruct the computer to pause or go to sleep for how many seconds before it executes the next instruction. So let's clear the shell. Let's bring that down a wee bit to give us some more room. And then at the very start of the program, you should always import things into your program at the start. So what we want to import is a module called time. It's full of subprograms that we can use in our code. I'm going to close that variable window to give it so you can see the code. So import time, and we're printing out start engines, and then we're going round our loop, starting at 10, going back to 1, and we're iterating through it negatively. We're stepping backwards, and we're printing out aligned centrally these values that are stored in loop counter, and then we're printing out blast off. So to slow it down, it would, before it goes back up to the loop, we could put our statement in here to do that. So we could say time.sleep, and inside these brackets how long we want it to sleep for. So let's say we start it off at 1 second. Let's try that. Okay, Control S. I'm going to bring this up so that we can see the output again, and F5. So start 8, 7, 6, 5, 4, 3, 2, 1, blast off. Excellent. I would say we have solved this problem. What we could do is put a title into it. So instead of print start engines, we could add a message here at the start that says print, and it's the Apollo 11 space mission. Right, let's do that. So I want to clear my shell, pop that back up, Control S, F5. So Apollo 11 space mission, start engines, 2, 1, blast off. Perfect. And the program has terminated. So you can see that you can indent the code that's indented inside your for loop is executed repeatedly. There is a variable that acts as a loop counter, and the range, the value that's placed in here, determines the order that the numbers will be executed in, and also how many times the loop will execute. We also practiced formatting our text, center aligning it, and we also were introduced to importing the time module and using time, the sleep function within the time module. Good. Now that you know this, you should practice your own programs. Make sure you have this program and make sure that you comment it. Put your name, the date that you create it, and your triple speech marks comment to explain what this program does. Then when you look back at the program, you will understand what you're looking at.